Accelerated Math 6-7 students, we are working in Module 6, and this is going to be Lesson 4. And Lesson 4 is called Variability in a Data Distribution. Variability in a Data Distribution. Okay? And let me get our notes together for this one. Variability in a data distribution. Okay, so our goal. Today we will learn how data must be judged by its variability as well as its mean. Okay, now a lot of these words seem kind of weird and kind of difficult to understand, but hopefully by the end of the lesson you will understand what it means. The question that I want you to think about is, when your mean values are the same, how do you know which one has a better indicator? Okay, and so what we have to do is we're going to figure out which one is a better picture or a better idea of what the data is trying to represent. All right, so it says, what does the data show? And basically, this is a little activity that we're going to use the information that we've been learning to take a look at it to see which one would be a better way to look at. All right, so we have soccer games, okay? And we are given the boys' goals, and then we are also given the girls' goals. And with the boys' goals, it says that they scored 0, 5, 3, 7, 0, and 3. Okay? And so we have that to help us see it. And then the girls' goals are 2, 3, 5, 2, 3, and 3. Okay. So the first thing that it tells us to do to help us look and understand at the variability of this data is draw a dot plot for each data set. Okay, so we're going to draw a dot plot. So I'm going to do the dot plot for the boys in green. So remembering all of these skills on how to do a dot plot, it's just a horizontal number line. I'm going to label it as boys goals because all dot plots have to have a title. Okay. And I'm looking at my number ranges, and I have 0, 5, 3, 7, 0, and 3. And so it looks like 7 is my highest and 0 is my lowest. So I'm just going to put my numbers on there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll label it like that just because that's the room that I had. Okay, and now what I have to do is I have to put a dot because we're doing a dot plot. So it says draw a dot plot for each set of data. So we're doing the boys, so I'm going to have 1 at 0, put a dot, 1 at 5, put a dot, 1 at 3, put a dot, 1 at 7, put a dot, 1 at 0, so I have to put it on top, and another 1 at 3, so I have to put it on top. So there's our dot plot for the boys' goals. Okay, so now I'm going to do another dot plot, and this time I'm going to plot them for the girls. So again, we have to have a title, so girls' goals. And I'm actually going to draw it exactly the same way so we can have a true comparison. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so my graphs look very similar. It would help if you could see them. Thank you. There we go. All right, and now I have to put the dots on this one. So the girls' goals, I have a dot at 2, a dot at 3, a dot at 5, a dot at 2, a dot at 3, and another dot at 3. Okay, so that is what the dot plot for the girls' goals looks like. Okay, so going back up here, it says draw a dot plot for each set of data. Determine the mean for each set of data. Okay, so remember the mean means the fair share. So what does everybody get? So if we go back up here to the boys, okay, we see that all of them get the fair share. And numerically, the way that we can figure out the mean is we would take 0, 5, 3, 7, 0, and 3 and add them all together. So that's 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is 18. And we have 1, 2, 3, 4, 5, 6 kids. So then we're going to take 18 and we're going to divide it by 6 and we get 3. So the boys' mean goals are 3. Okay, so now let's look at the girls. So we're taking the girls' mean, and we have 2, 3, 5, 2, 3, and 3. Add those together, and we get 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 also. 1, 2, 3, 4, 5, 6. Divide that by 6, and we get 3. So the mean for the girls' goals is also 3. Okay? And so, as you can see, it says right up here in the question, when the mean values are the same, so the means are the same, they're both 3, how do you know which has a better indicator? And remember, we're looking for variability, okay? Variability means the ability to show things vary in your goals. And so when we say goals, we're talking exactly about soccer game goals, okay? So if we're looking for variability on these two graphs, what is the variability on the boys' goals? Are all of the goals spread out, or are they all clumped in one spot? On the girls, are they spread out, or are they all clumped in one spot? Well, if I was looking at these two graphs to determine which one has better variability, that means more variability, then I would say that the boys has more variability because they're spread out more. They're not just in one clump. If you look at the girls' goals all seem to be clumped right around 2 or 3. Whereas if you look at the boys' goals, they have 2 at 0, they have 2 at 3, they have 1 at 5, and 1 at 7. At the girls, they have 2 at 2, 3 at 3, and 1 at 5. So they're not very spread out. So variability, which data set has better variability? I would say the boys' data set has better variability because their goals are more spread out according to the graph. The girls does not have good variability because they're all clumped in one space. Even though they both have the same mean, which gives us very information, the mean average score for boys is 3, the mean average score for girls is 3, but the boys have their goals spread out, whereas the girls' goals are all clumped together. Okay? So, going back to our title is Variability in a Data Distribution. So that means, are they spread out or are they all clumped together? I would say, looking at these two graphs, again, that the boys is spread out and the girls is all clumped together. So today we will learn how data must be judged by its variability as well as its mean, because both teams have a mean score of 3, but that does not tell us that anything about the variability. What tells us about the variability is how those points are spread out and how they look on the graph, and the graph really does tell us. So I would say high variability on this one. I would say low variability on this one. So boys is high and girls is low. Going back to the question, when your mean values are the same, how do you know which one has a better indicator? The way you know which one has a better indicator is based on how your dots on your dot plot are spread out. A lot of spread out means high variability. All clumped close together means low variability because it doesn't. There aren't a lot of different choices. Okay, and that's what we have about variability in data distribution. Okay, that's it. I'll talk to you soon. Bye.